Hello everyone, it's Robert with SparkFun Electronics. We're back from hiatus and we're back from Thanksgiving and we're back from announcing Free Day 2012. So we're back to another new product post, another new product video, and we've got a bunch of stuff to talk about. So let's see what we've got for this week. So first up, we've got a new Arduino to talk about. This is the Arduino Uno R3, Revision 3, V3, any of those names. This one is a lot like the old Uno, but there's a couple of key differences. First off, you'll see that we actually have a couple extra pins here on the header. Over here we've got the SDA and SCL line that are broken out to right there. We've also got the reset pin has moved over there. And over here we've got an IO ref pin and another pin that is going to be used in the future. Now the theory is that there's going to be new shields that when you plug them in, they're actually going to be able to read the reference voltage off of the Uno and do some other cool stuff like that. Ultimately, it's the same Uno, and it works the same way, but it does use the Atmega 16U2 instead of the 8U2. So it's an interesting board. It's a lot like the old Uno, but with a couple small improvements. So check out the new Uno. Here we've got a new LCD screen. This is a 2.6-inch touchscreen color LCD. This is the EZ LCD 301. The interesting thing about this is you can actually run programs directly from this, you can program directly onto this, or you can use it with another microcontroller and just send serial commands to it to have it do whatever you want. When you plug it in, it shows up as a mass storage device, and you can actually load programs directly onto the folders and have them start up as soon as you plug it in. So it's pretty versatile. With the touchscreen, with the easy-to-use command interface, you can do a lot of really complex things with this, and you can do it all standalone, so you don't necessarily need a microcontroller. It comes with this USB cable, which has all these wire leads coming off of it, as you can see, and this just plugs directly into the back. And this is where you get all your communication. You even have a couple of basic input-output pins here. And if we can plug it in, you can see just how it looks. So there you go, and you can see that it's loading its default image right now. And that's about what it looks like. And there is an example on the product page of how you can connect this directly to your Arduino. And there's even a little basic Arduino library written for it, so you can use your Arduino to directly talk to this screen. So here we've got bare Conductive Paint. This is Conductive Paint. So we've got a lot of different, conductive e-textile stuff. We've got threads and fabrics and ribbons. But this is the first Conductive Paint that we have. It is this nice glorious black color, and it's pretty thick actually, as you can see. But what you can use this for is painting on fabrics, painting on any kind of different textiles, or painting on paper or anything else. And you can create resistors with it, you can create circuits with it, and you can do all sorts of interesting things with it. We've got a couple of demos to show you some of the things that we've come up with, and let's take a look at those. Here we've got an interesting little demo that my assistant Nick put together. We've just got a white canvas here, and we've got some conductive paint on it. We've got an Arduino and a battery and a couple of LEDs. And the first thing we've got going on here is this little patch over here. This is a pad of the conductive paint, and it's covered over with a white acrylic. It leads back to the Arduino through a 1 mega ohm resistor and into the Arduino. We're running the capacitive touch library so that when we touch this pad, we can see this LED go on. And you can see it cycles from this one back and forth. So you can use this conductive paint as a capacitive touch sensor on a piece of fabric or a piece of canvas. The other thing that we're using this for is this trace over here is hooked up as a potentiometer. This conductive paint does have a resistance to it, so at this point, there is very little resistance, but as we increase here, there is a greater resistance. And if we watch this LED here, we can actually increase and decrease the amount of resistance on this LED and make it go brighter or dimmer. So you might be interested to know exactly what the resistance of the conductive paint actually is. And fortunately we don't have a data sheet on it, but we decided to put together this little demo. Here we've got different stripes that we've painted with the conductive paint, and we can easily tell the resistance based on how thick the trace is and how long the trace is. So we've got 1, 2, 3, 4 different traces. We've got a 1/4 inch, 1/2 inch, 3/4 inch, and 1 inch thick that we just brushed on, relatively thin. We didn't glob it all on there. And we've got different values. These values are all going to be posted on the product page so you can see this. But if we just take a look at our meter over here, we've got this 1/4 inch trace. Now if we put one of the meter leads at the beginning of it and go, oh, I don't know, about 3 inches in, we can see that the meter is reading a value of almost 500 ohms. And that's good because our 1/4 inch thick trace actually has a resistance of about 150 ohms per inch. And if we go a little bit further along in the trace, you can see that we get up to about 1K worth of resistance. Yep, right over 1K. Now, that's the 1/4 inch trace. If we go down to this 1 inch wide trace, there's going to be a lot less resistance because it's a lot bigger and thicker trace. So if we put our meter right there at the beginning, and let's say about halfway in, you can see it has very little resistance. And if we go all the way out to the end, yeah, a little bit more. So the interesting thing about this paint is you can actually adjust just how much resistance you want based on the width of the trace and the length of the trace. So pretty interesting to see. So this gives you a really good idea of how much resistance there is in the new conductive paint. Here we've got a really small breakout board. This is a breakout board for the VCNL 4000. And as you can see, it is a very tiny little board. The VCNL 4000 is a combination IC of an ambient light detector, an infrared detector, and an infrared emitter, all in one package. So not only can you read the ambient light coming into the sensor, but you can also detect the reflected infrared. So the way an infrared detector works, simply, is it has an infrared light source that comes off of it, and then a sensor that detects infrared. So when you pass your hand over it, the reflected infrared will reflect back into the chip and be detected, and it can tell about how far you are away. Now this sensor has a range of about 20 centimeters, which is something like 7.870 something inches, so it's only about like that. In reality, it works a lot closer range, and you can see this demo that we're going to do later. The range works a lot closer, and that is because the infrared light kind of spills out and doesn't necessarily directly get reflected back into the IC. So there's that. We do have really good example code on this that will allow you to just hook this up to an Arduino and spit out the ambient light value and the reflected infrared proximity light value as well. So let's hook this up to a demo and see what happens. So here we're using the example code with a couple modifications for, the video. We've got the board hooked up just like the example code says, but we've got a series of 6 LEDs. And essentially what's happening is we've just got a switch case statement that says if we're in this range, do this, if we're in this range, blah, blah, blah. And the switch case will actually light more LEDs as we start to approach closer to the infrared sensor. So you can see, just the one is on right here. And as we start to move closer, more of them turn on. Now, this particular IC, the output seems to be very logarithmic, so the closer you get, the value starts to spike up really high. Hence, around here is where it should start to detect, but there's just a lot of noise and stuff because of the ambient lights in the room and everything else. A real good range is from about here to here. That's where it's most sensitive. Now, I'm sure you could probably do something to isolate it, make a tube around it or whatever. It can detect out to 20 centimeters. It's just for this demo with the open air and everything, it really doesn't. But you can see that you can easily use this for possibly a contactless switch or proximity detector or anything like that. So it's pretty interesting and pretty inexpensive board that can do a lot of different things. So there you have it, another Friday product post. Actually 2 weeks worth of Friday product posts, I guess, ultimately. We've got some paint, we've got an LCD, we've got the new Uno, and we've got the infrared sensor. So check out the rest of the product post. We have a lot more on there, and we'll see you again next week with even more new products.